Here is an acid-base neutralization reaction, and this is also a grams to grams stoichiometry problem. We have 2.35 grams of phosphoric acid combined with the base sodium hydroxide, and our two products are water and an ionic compound. We want to calculate how many grams of water will be produced when this acid base neutralize each other. Checking for a balanced chemical reaction, this is not. We have 1 sodium here and 3 sodiums here. So firstly, we will balance it. Secondly, we will solve the grams to grams problem. When balancing chemical reactions, let's start with our ledger by running our atoms vertically down the center, and then our accordions where we stretch out these formulas. Four hydrogens, 1 phosphorus, 5 oxygens, and 1 sodium. These accordions are not structurally accurate, but they are mass to mass accurate. 3 sodiums, 1 phosphorus, 5 oxygens, 2 hydrogens. So our phosphorus and our oxygens are squared away. Let's focus on the sodiums. We need 3 sodiums total on this side. So when balancing using Mother Nature's proportions, we cannot pick and choose. We have to use the entire compound. So now we have 3 sodiums, 6 hydrogens, 7 oxygens, and 1 phosphorus. Sodiums are balanced. Phosphorus is still balanced. Oxygen is balanced. Hydrogen. I'm going to balance hydrogen because that's an easy ratio over here to get 6. Again, I have to copy and make like a Xerox copy of that molecule every time. 6 hydrogens, still only 1 phosphorus, 4, 5, 6, 7, and 3. My ledger looks like this is balanced. Let me double check. 6, 1, 4, 5, 6, 7, 3 sodiums. 3 sodiums, 1 phosphorus, 4, 5, 6, 7. Good. My ledger is proof that this is balanced. And what that tells me is there is one of these and 3 equivalents of those, and 1 equivalent of that will be produced, and 3 equivalents of that will be produced. This is step 1, balancing our chemical reaction, and now we can solve the grams to grams question. When students have trouble balancing chemical reactions, the accordion stretching out of the formulas are the first thing that I don't see on their paper. In our shopping list of the question, we are only given one number in unit, 2.35 grams of H3PO4 phosphoric acid. So our scaffold has the only place to start in there. To compare the ratios from the balanced chemical reactions, this 1 to 3, we first need to convert this into moles. So we go to our periodic table and add up 3 hydrogens, 1 phosphorus, 4 oxygens. That is 98 grams per mole. Now, as I write that number and unit down in there, a unit does not cancel. So I flip this to make a word cancel on every step. There we go. This was summed from the periodic table. Grams to grams cancel. Now I can compare the ratios from the balanced chemical reaction, 1 H3PO4 and 3 water. Sticking with making a word cancel out every time, if H3PO4 is on top here, I need that on the bottom here. Don't forget to carry from the balanced chemical reaction. This must be the place that the 3H2O travels to. Again, I flip as necessary to make a word cancel. If I were to stop my calculation here at my calculator, the number I would get would have the units moles of H2O. I want it in grams. So we go back to our periodic table, add up 1 oxygen, 2 hydrogens, and we get 18 grams per mole. And as that floats in there, moles cancel. Now, with the only words left surviving is grams and H2O, now I can pick up my calculator and solve this multiply and divide accordingly. Thank you.